Hello! Welcome again to April's biomedical course. Last time, we've learned how to count cells using the haemocytometer on the usual samples. By usual samples, what I mean is that the concentration of the cells within our sample is not so dense, it's not so high. And now, for this video, today we're going to cover how to count cells using the haemocytometer with another counting method, which is when the concentration of the cells within our sample is extremely high, is extremely dense. So before, if you haven't watched the video before, then I suggest that you watch the video before first. You can see the link down below in my description. And in that previous counting method, we either count all the cells within the big cells, so we count the whole cells within the whole grid, or we can count the cells within 5 big cells. Big cell number 1, number 3, number 5, number 7, and number 9. But we're not going to do that here. In the case of such extremely dense cell concentration, we will only count cells that are present or contained within the big cell number 5, which is this one in the middle. And again, please do not forget to subscribe to this channel, and don't forget to give my videos a thumbs up if you like it, and share it with your friends. You might help people and you might help some friends, you never know. And really, very much please, if you have any materials that you want me to cover, just write it in the comments. And please very much subscribe to my channel, because of course, number one, it will give me more motivation to cover more subjects in the future. Whatever you want, whatever you need, just tell me in the comments and I'll do it for you. And number two, please subscribe because it'll help me with my rent. So please do. Thank you. So, as I've said before, as we've covered before, the haemocytometer is basically a counting chamber device. It's used originally for counting blood cells, but nowadays we have been using them for counting more cells, more types of cells, and all of them are usually research related. And as we've covered before, the types of cells that we can count is bacterial and yeast cells, and then bacterial and fungal spores, red blood cells, and other types of blood cells in our blood sample, and also for cell culture purposes, the primary cells and the cell lines. And we can see here that this is the tool. We have the grid over here, up here, and down here. If you can see it, it's vague there, but it's actually there. And this is how each grid looks like. We've covered the volume of the haemocytometer, and we've also covered why it's important to know the volume of the haemocytometer in the last video, right? So that's 0.1 microliter. And the counting method for conditions where the sample is not that abundant, what I mean is that when we have samples with the concentration of cells of lower than 10 to the power of 6 or 10 to the power of 7, we can use this strategy. And one way to know if it's that is if if you see this small cell over here and you only see about 1 or 2 cells crammed in there, that's still fine. But if you can see 3, or actually let's just say 10, 20, 50 cells crammed in literally one small cell here, okay, you do not want to use this counting method, okay? So yeah, again, this is the example of a sample having the concentration of cells that are not so abundant, okay? So the concentration is not so abundant here. Some small cells do not have any cells at all. Some have 1, some maybe have 2. These are quite close together. You can see that it almost touches 2 for this cell. This one, well, yeah, you can see that's quite as 2, right? Oh, see, this one has 2, this one has 2. That's still fine. But if you have in this one small cell 10 crammed together, and they're quite small, so yeah, you might not want to use this counting method. So the alternative to that is this one. So basically, we count only the cells within big cell number 5. And what we want is actually we want to count all of the cells within this big cell number 5. So we count every cell within this big cell, right? But if it's too much for your eyes and you don't really want to waste time, you can just count 5 cells from this big cell, okay? And the location is dotted with, yes, these purple circles, okay? So just count 5 cells, not at random, at these places. Okay, those are good sampling places, and then afterwards, later you will see that we are going to multiply that with 5. Why 5? So basically, in this big cell number 5, we have 25 small cells, right? And we already have the data for 5 small cells. So that's a fifth of the total cells within. So all we need to do is just count the total cells that these 5 cells have, and then we multiply the total number with 5, and that represents the whole cells contained within the big cell number 5. In alternative to that, if you want to, or if you can, then you don't need to count. You don't need to multiply the total number with 5. You just need to count all of the cells here. Just count all cells contained within big cell number 5. Okay. And then what do you do with that information? Okay. So here's the deal. This is the example here. Okay. So within this big cell number 5, okay, we have 25 small cells, and we are counting with the first method, which is we count only 5 small cells within, okay? So small cell number 1 has 53, the other one has 51, the other has 54, 52, and 50. The dilution factor is the same, it's 2, and for the explanation of dilution factor, please refer to my video before. Okay, so what do we do now? Okay, so the first thing to do, as I've stated before, all we need to do is just add all of them. Okay, so we get the total number from these 5 small cells, and we obtain the number of 260 cells. Okay, afterwards, we need to multiply them with 5 so that we know the whole cells contained within big cell number 5, and we get the number of 1,300 cells. Afterwards, then finally, we can put this number into the formula that I have explained in the video before. All we need to do is multiply the number of total cells with 1 milliliter and divide them with 0.1 microliter. Okay, and an easier way to remember that is just this. If we have 1,300 cells in the volume of 0.1 microliters, that's the volume for one big cell, right? How many cells would you have in the sample if the volume is 1 milliliter? With that logic in mind, we already get this formula, and with that we get the number, the final number, 1.3 times 10 to the power of 7 cells per milliliter. Okay, but remember, we have a dilution factor here, right? So we've diluted our 10 microliter sample into 2 microliter mixture because we add 10 microliter of tryphin blue, right? So this is actually the number of cells in this one, okay? It's the diluted version of our initial sample. So do not forget, we need to add the dilution factor into the formula. All we need to do is just have that, have this final number here, and you just multiply that with the dilution factor. Since our total mixture volume is 20 microliters and our initial sample is 10 microliters, then the dilution factor is 2. Okay, so we just multiply. In short, we just multiply this number with 2 actually, and then we get this final number, 2.6 times 10 to the power of 7 cells per milliliter, and this is the real concentration within this sample. Okay, in the volume of 1 milliliter, of course, not in the volume of 10 microliters. Okay, so that's actually everything, and the counting method is exactly the same when we count all the cells in big cell number 5. Okay, all we need to do is just, well, we do not, in the condition that you count every cell within this compartment, within this big cell number 5, you basically skip to this part. You already have the total numbers here, right? And then you just skip it here. So you don't need to do this part, okay? So just know which one are you doing, and you'll be fine. And that's basically all for my video today. Thank you for listening to my explanation. If you want to revisit the video before, then just look into the description, and there's a link over there. You can just watch it again there. And very much please subscribe to this channel, and please give my videos a thumbs up if you like it, and please share this video to your friends. You never know, you might help a friend. And again, please comment on what materials or subjects you want me to cover, and please subscribe to this channel because it would very much help me and motivate me to make new contents every week, or sooner if you would like, and it would very much pay for my rent. Again, thank you. Peace out.